Hello, and welcome to today's edition of Talking to a Biologist. Today we're with Dr. Anne Worley in the Department of Biological Sciences. Welcome, Anne.
Thank you.
So tell us a little bit about yourself. What was your first inkling in your life that you wanted to do something in the life sciences?
Well, I grew up in the Okanagan, and my parents actually live next to a provincial park in the Okanagan. So when I was about 13, we moved out there, and I started spending a lot of time, first of all, walking the dog, and then just walking for my own sake in a grassland provincial park there. Did a lot of swimming, a lot of hiking as a family, so I really liked being outside. I liked plants, animals as well, of course. I also like the idea of genetics and evolution, which is part of what I study, although I'm not sure at that time that I really knew what that meant.
Well, that sounds interesting. So when you grew up loving sort of the outdoors and plants in general, what then academic career did you follow? Did you, when you went to university, and where did you go to university?
I did my undergraduate degree at University of Victoria, and I was in the biology co-op program there. So that had appeal for me because I didn't know when I started what I wanted to do when I finished. I didn't know if I wanted to follow an academic career, if I wanted to be in the workforce. So that was a way I could get practical experience in biology and also enjoy myself, get out in the field, that kind of thing.
And when did you decide that, plant molecular genetics might be just the place for you?
Well, the plant part, I guess, came in about my third year. I like the idea of plants partly because they're aesthetically appealing. There's a big aesthetic component to my research, partly because not everybody wanted to study plants, so I wanted to be a little bit offside of the mainstream, and partly because they seem quite accessible as study organisms. They don't run away.
So tell us a little bit about your research.
Okay, well, I guess the main area that I'm working in is plant reproductive biology, plant reproductive evolution, and plants have a particular challenge that you might not think about every day, I guess, is they can't run around to find mates. So they're essentially relying on either air currents or fooling unsuspecting animal vectors into visiting them. So a lot of the showy display that you see in natural wildflower meadows or alpine meadows is all about sex. It's all about reproduction and all about getting your genes to the next generation. And so part of what I'm interested in is how plants attract pollinators and how they manipulate pollinators in order to achieve the goal of reproductive success. So that's part of what I'm doing, and I have a student who's working on a species that's visited by both hawk moths and hummingbirds. So he's comparing selection, natural selection imposed by both of those species on the plant. Another interest of mine goes back to my undergraduate days is in conservation. And so one of the projects that I'm collaborating on with Dr. Bruce Ford, who's another member of the department, is pollination biology and hybridization between two tallgrass prairie species that happen to be orchids. So they have this real aesthetic appeal because they're orchids. One of them is endangered because it's native to the tallgrass prairie. And the other one is very widespread and very common. So it's essentially a weedy orchid.
Cool, a weedy orchid.
Orchid, yeah.
But I found that very interesting. So manipulation and showy displays are part of plant sex as well.
Yes.
So the students will find that all very interesting, that it's common across all of the various biological systems. Well, tell us more about the rare orchid.
Well, the rare orchid also incorporates deceit into its reproductive strategy. So this orchid looks appealing, it smells appealing, and it is occasionally visited by insects, but it actually contains no reward. The flower is slipper-shaped, and it's essentially a trap. And so what happens is the insects go in expecting a reward and find no reward, plus they can't get out. And the only way they can get out is to squeeze past the sex organs. And so we're interested in that strategy as well, and what the implications of that strategy are for reproductive success for the whole community in the tallgrass prairie. So that's part of what we're doing.
Well, thank you very much, Anne, and that concludes today's issue of Talking to a Biologist, and I hope you all found that interesting. There is many, many commonalities across all the different groups. Evolution is driving it all, as you'll find out as we go through the course. Thank you all very much.